Today, we have our third round with the development of nuclear weapons. In the first, we looked at the theory and history of fission. In the second, we looked at the bomb project and how it transformed science and the relationship of science and the state. And in this lecture, we're looking at the development of nuclear weapons in their application, that is to say, in the use of atomic weapons over Japan at the end of World War II, and then in the development and proliferation of weapons in the Cold War and after. We begin with the dropping of the bomb. And the most important thing to understand about the bomb is that we have an all too easy assumption that it was always obvious that one or two atomic bombs would end World War II. At the time, the atomic bomb was assimilated into the long run of strategic bombing. You see, beginning in World War I, there had been the idea that somehow aircraft could control the destiny of a war, and decide the outcome of a conflict. People began to think about destroying what were called vital centers of a society and cities, and taking out a ball bearing factory or a chemical factory or other particular places and sites of production that could grind a society and a war-making machine to a stop. But in World War I, planes played a relatively small role in the conflict, aside from photographic reconnaissance. In World War II, that changed, and both sides, the Axis and the Allies, began to use airplanes and the bombing of cities to destroy whole strategic regions. This began in a sort of test phase by the Nazis in their catastrophic attack on Guernica that's depicted so famously by Picasso. And then, over the course of the war, the Blitz, the attack on London, which took many thousands of lives, and then the British and the Americans began a program of systematically attacking the major German stronghold cities in an effort to crush the Axis in their ability to conduct the war. Those raids, which culminated in the firebombing of places like Dresden and in the Far East by the bombing of city after city, up to and including Tokyo on March 10th or so, 1945, and in that combined bombing of the 9th, 10th March 1945, almost 100,000 people in Tokyo were killed. It had an absolutely devastating effect. But by the time the atomic bomb was ready for testing and then eventually use in the summer of 1945, it had already been established that large aerial attacks on whole cities had become the norm. And the atomic bomb was not going to be produced in one or two instances. These huge factories at Oak Ridge, at Hanford, these production of uranium-235 and plutonium were part of a factory system that would be issuing atomic bombs the way the United States was producing aircraft carriers, destroyers, and bombers. This was to be a systematic, very large-scale industrial effort. And the bombs would take out city after city. So when the atomic bombing of Japan occurred, there had been relatively little discussion in American scientific circles, certainly, about whether this was moral or immoral or following the rules of war or not. So much pressure, so much effort, so many billions of dollars had gone into this development, and the destruction of cities had unfolded over the course of an immensely destructive world war that had taken by then some 50 million lives, that the issue of the bomb as a particular moral political problem didn't really occur. It was going to be used as soon as it was ready, and when it was used, it would have a combination of military and political consequences, a combination of stopping Japan cold, removing the necessity of a land invasion of the main part of the Japanese state, of serving as a deterrent and warning and stopping the Soviet Union and its possible expansion into this region. It had many different reasons and propulsions towards the use of that bomb. And after the second bomb over Nagasaki was deployed, it did in fact bring the war to a close. It continues to be a debate among historians about whether or when the Japanese would have surrendered absent the atomic bomb, and whether they were in fact essentially in a position not to be able to continue too much longer. But those debates still are in the domain of the hypothetical counterfactual. In the event the bomb was deployed against Hiroshima and Nagasaki on the 7th and 9th of August 1945 to devastating effect. And the images of that attack had a tremendous effect on the American scientists who witnessed them. They had been, in a way, surrounded by a world of intense work, pushing as absolutely hard as they could in this all-out war, not hesitating or missing really a beat after the surrender of Germany, which had been their original motivation for building the bomb, the fear that the Nazis might get the bomb first. But when the European surrender occurred, the American scientists pushed on, except for a small group of scientists who began to raise questions, especially in Chicago in those last months of the war. On the whole, political, moral questioning of the bomb among scientists was not part of the equation. But after the war, a discussion did break out, because in 1949, in the summer, the Russians detonated their first nuclear weapon. Everyone had known that eventually the Soviet Union would get a nuclear weapon, and everyone always said, well, it'll be 4 or 5 years, and they said that in 45, 46, 47, 48, and somehow nobody quite did the math and realized that by 1949, 4 or 5 years was coming to a close, and in fact they detonated a bomb which the Americans dubbed Joe 1 after Stalin. That bomb precipitated a huge debate in the American scientific circles. Suddenly, what had been a distant possibility became an immediate reality. And the question became, should the Americans go ahead and build another kind of bomb, one they'd been discussing on and off since really the beginning of American involvement in World War II, namely to build a hydrogen bomb, a bomb potentially as many times more powerful than the atomic bomb. Then the atomic bomb was then a blockbuster 2,000-pound bomb that had been used with conventional explosives during World War II. In fact, in the early days when the scientists who were really leading the effort to build the atomic bomb got together, they thought the atomic bomb was such a trivial matter that they assigned it to a young physicist and said, why don't you just figure out how to make an atomic bomb? The rest of us, more senior physicists, will talk about the really interesting, difficult problem of building a hydrogen bomb. Well, the atomic bomb turned out to be much more difficult than anybody had thought in those early days, and it had taken all of their attention to build it. Edward Teller, one of the leading physicists of the time and one of the leading figures in the A-bomb project, became fascinated by the H-bomb and refused his friend and the group leader of all the theorists at Los Alamos the pressure to work on the atomic bomb, and he spent almost the entire war trying to think of a way to build the H-bomb. But in 1949, when the Russian bomb was detonated, suddenly that debate erupted. Many physicists refused to work on it, and there was a huge argument back and forth about whether scientists had a particular obligation to build it or not to build it. The effects when the bomb was finally designed, built, and deployed were huge. It spiraled up the United States, USSR arms race a big step up, because suddenly you had a bomb that was powerful enough not just to destroy the center of a relatively small city like Hiroshima, but to destroy the entirety of a major world city like London, Moscow, or New York. Second, it generated a kind of internal arms race because it led to the development of a second weapons laboratory in the United States at Livermore, and the friction and competition between Livermore and Los Alamos was each side constantly vying for control of more of the nuclear development pie. Third, it displaced civilian scientists from the center of the action. In a sense, because many of them objected, and eventually publicly, to the building of nuclear weapons, the military and governmental authorities became ever more reluctant to have the development of nuclear weapons in the hands of civilian scientists whom they really couldn't control. And fourth, Oppenheimer himself, who came to resist very strongly and in a well-known way the building of the hydrogen bomb, was eventually put on what came to be known as a trial. It was a security hearing in April of 1954, and it led to the dismissal of Oppenheimer, perhaps the most powerful American scientist of the time, from the corridors of power and secret consultation.